It's helping us learn what became of those black holes that formed in their wake. Astronomers believe some grew huge by plowing their way to the centers of their host galaxies, where they gorged on a rich supply of gas and stars. Some black holes grew larger still when they crossed paths with others.
They go bigger.
This scientific simulation traces the collision of galaxies, a drama that plays out over 2 billion years' time.
What's gonna happen when they hit together?
The two galaxies become one. The black holes in their centers merge into a single powerhouse of staggering size. The gas hurtling into it gets jammed.
So, the gas is that middle core is a galaxy. That middle core that I'm pointing to is a galaxy.
I
mean, is a black hole that's just
thousands of light years into space. They may lay the framework of the new galaxy, sculpting its size and shape and stocking it with something unexpected. Black holes may be one of the chief ways galaxies get seeded with elements generated by stars, with carbon, oxygen, and iron, the stuff of solar systems, and us. So how did our galaxy make out to move this? Astronomer Andrea Ghez wants to know, have we got a supermassive black hole of our own? For more than a decade, she and her team have been coming to the heights of Hawaii's Mauna Kea volcano to find out. Working at the giant Keck telescope, Andrea is tracking a strange presence in the center of our galaxy.
See?
A group of stars is swirling around it, and she's clocking their speeds, projecting their orbits.
That's what they see?
Her telescope is so powerful, it can peer through the thick of the Milky Way, through 26,000 light years of cosmic dust, all the way to the stars at the galactic center. Whatever's got them in its grip, it's accelerating the ones closest to speeds of up to 3 million miles per hour.
Wow.
Given that, Andrea and her team calculate that the culprit weighs in at almost 4 million times the mass of our sun.
Wow.
Solid evidence that at the exact center of our galaxy lurks a supermassive black hole.
So that's a black hole.
Andrea has confirmed the black hole is there without actually seeing it. So we're left to wonder, what's it like up close and personal?
With the black hole,
We can stop wondering and pay the monster of the Milky Way a visit. There's no spacecraft heading there anytime soon, but that's not stopping us. We'll get there courtesy of the latest telescope observations and computer models.
This is amazing.
We're just leaving the suburb where we live, about halfway out from the center of the galaxy.
You take pictures, I take video.
The Milky Way stretches before us. It's so large that it takes a beam of light 100,000 years to cross from one end to the other.
Wow. 1,000 years to cross from what?
100,000 years to get from one side to the other.
Of what?
The black hole.
What about Earth? How many days does it take to go from one side to the other on Earth?
Next stop, our galaxy's central hub, brimming with stars,
2 days on an
known
airplane.
simply as the Bulge. The farther we travel from our quiet cul-de-sac, the more crowded it gets. Up ahead, it's one big traffic jam of dust, stars, and hot gas. And it's always rush hour. Approaching dead center. The way is already strewn with signs of havoc. Supernova remnants and swirling clouds.
It's a black hole.
Our course so far has been charted by astronomers like Andrea. They've plotted the landmarks by how they register across the light spectrum, from radio waves to X-rays. But here, their observations reveal a no man's land, an inner zone cleared by the voracious appetite looming ahead. A cloud of super-hot gas is swirling around it. The black hole pulls the gas in, then spews much of it back out. Now things get really strange. What you are seeing is not the stuff of Hollywood special effects. It represents the first time scientists have visualized the journey into a black hole.
We're going in a black hole?
Is Einstein and what his equations tell them. Space here is so warped, the black hole acts like a giant lens, twisting the light that scatters across it.
That's huge.
At last, we cross the event horizon, the point of no return. But don't expect the inside of the black hole to be dark. Swirling within is a maelstrom of energy and matter. Hidden in the chaos is a single point where the black hole's mass is packed, known as the singularity. Now imagine there's an eye to the storm, magically made calm, so all the strange predictions of Einstein's equations can play out. We'd be greeted by a passageway, an escape hatch in space and time known as a wormhole. Through it, we enter a white hole.
Whoa.
Here, the same twisted logic holds in reverse.